So in this lecture, we are going to learn about epsilon closure of a state. So previously we had learned about how to construct an NFA. Like we have seen R is equal to A plus B, R is equal to A star. So we get these states. Now epsilon closure of a state, it is defined as set of states that are reachable from that state by walking on epsilon transitions, including that state. So set of states that are reachable by walking on epsilon transitions. So we'll see an example like R is equal to A plus B. So here, suppose we want to check epsilon closure of 0. So epsilon closure of 0. Set of all states that are reachable from 0 on epsilon transition, including the state. So 0 is included first. Then if you see in the diagram, 0 to 1 is reachable. So 1 will also be included. 0 to 3 is reachable. 0 to 2 is not reachable through epsilon. Suppose there were 2 epsilon, then we could have added that. So here in this case, we are having only 0 to 1 and 0 to 3. So we get 0, 1 and 3. They are reachable on epsilon transitions. Epsilon is nothing but no input string. So this is for 0 in R is equal to A plus B. Suppose we want to calculate for 2, epsilon closure of 2 for R is equal to A plus B. So it will have 2 including the state. So first 2 will come. Then there's no transition from 2 to 1 or 2 to 4, but there's a transition from 2 to 5. So 2 and 5 will be the states. So this is very important. This we require for the conversion. So sometimes we get question regular expression to NFA, NFA to DFA. So that conversion, we should remember how to get the epsilon closure. Then only we'll be able to do the conversion. Now let us see another example. R is equal to A star. So we will calculate R is equal to A star. For that epsilon closure of certain states we will calculate. So here epsilon closure of 0. So epsilon closure of 0 in this case, first the state should be included. Then from 0 to 1 there is a transition on epsilon as the input. Yes. Then 1 to 2 is on A, so we cannot take it. 0 to 3 there is a transition. It is possible on epsilon as the input. Then 0 to 2 it is not possible. So that cannot be included. Now epsilon closure of 2. So epsilon closure of 2, first include the state. So we start with 2. On getting epsilon as input, we have a transition to 1. So 1 will also be included. On getting epsilon as input, there is a transition to 3. So that will also get included. 0 will not get included, but is because there is no transition towards 0. So the arrows are also very important. We'll take one more example. R is equal to A plus B the whole star. So in R is equal to A plus B the whole star, we'll find epsilon closure of 0. In the previous video, we have seen how do we draw this NFA diagram. So include the state first, then 0 to 1, there is a transition. From 1 to 2, yes, there is a transition. From 1 to 4, there is a transition. So these are epsilon transitions. Epsilon, epsilon 2 times is allowed. Epsilon A is not allowed. So epsilon, epsilon A. So we cannot go to 3. Epsilon, epsilon B, we cannot go to 5. So these are not reachable from 0. Then 0 to 7, yes, it is reachable. So that can be included. 7 to 6, there is no transition like this. Otherwise, we could have written. So these are the set of states that are reachable from zero. So this is very important. So this we require whenever we are converting an NFA into DFA. So we'll be learning about that in the next video, converting NFA to DFA. I hope so this is clear.